So your motor or efferent neurons and your sensory or your afferent neurons, these are myelinated through the central and the peripheral nervous system. Your interneurons are not myelinated. And the cortex, being that part of the brain that we just spent a lot of time when we were talking about the various different areas of the cortex, though that is all interneurons, that's all gray matter. It's unmyelinated. So before we get to talking about the cranial nerves, which is the motor pathways of the peripheral nervous system, let's take a moment and define the motor pathways, meaning the descending pathways of the central nervous system. And these are what we refer to as the upper motor neurons. So we already mentioned the primary motor cortex. So you have your primary motor cortex or your motor strip, which is the posterior most gyrus of the frontal lobe. So this, let's say this is a coronal slice of that. So here you have your cortex from the sensory, that is part of the sensory strip. So here in green, this is the part of your brain that creates your motor plans. And here's my hand down here. It's a Charlie Brown hand. It's going to have to do for now. So this motor plan that I have just made up here in the right side of my brain has to get down to the left side of my body. The pathway, the efferent pathway that motor plan is transmitted down along is referred to as the upper motor neuron. So here is, let's say, my hand movement. Gets planned, that motor plan gets generated right here, this part of my motor strip. Then it's going to be sent down along the upper motor neurons, down into the brainstem, midbrain pons, and it's going to get to the medulla, and it's going to decussate to the other side. And then it's going to travel down, still within my central nervous system. So the upper motor neuron are the efferent pathways within the central nervous system, and that includes, as you see here, the brain, the brainstem, decussating in the medulla, and then coming down into the spinal cord. The spinal cord is part of the central nervous system, so the motor pathways within the spinal cord are upper motor neuron. But now, this motor plan has to get from my spinal cord out to my hand. So it is going to travel now along the peripheral nervous system. So that peripheral nerve moving out to my hand, and so that motor plan now gets transmitted out to the muscles of my hand, and my hand moves. So the upper motor neurons are descending pathways within descending motor pathways within the central nervous system. And your motor pathways within the peripheral nervous system are referred to as your lower motor neurons. So the lower motor neurons exist within the cranial nerves and the spinal nerves, the peripheral nervous system. Okay, so let's look at this guy real quick. Instead of sending a motor plan out to my hand, let's say I'm going to send a motor plan out to my tongue. So up here at the motor strip, the motor plan is generated. The motor plan is sent down, we'll say this is right, this is the left side. So the left side of my motor strip is going to send a motor plan down along my upper motor neuron, and then it is going to decussate to the right side of my body at the medulla, and then it's going to come down a little bit more, still within my brainstem. And at this point, that motor plan has to get from my brainstem out to my tongue. The pathway it is going to take is the efferent, or the motor portion of that part of my peripheral nervous system that services my tongue. And in this case, we're talking about the hypoglossal nerve. So recall that the peripheral nervous system is divided into that part of your peripheral nervous system that services your head and neck. Those are your cranial nerves. And that part of your peripheral nervous system that services the rest of your body, and those are your spinal nerves. So now we're getting into the cranial nerves, which is that part of the peripheral nervous system that is associated with your head and your neck. And that is a picture of Brigitte Bardot, if you wanted to know. So, here is a picture of the brainstem. Most of the portions of the peripheral nervous system that service the head and the neck, meaning the cranial nerves, connect to the central nervous system at the brainstem. And we talk about them by Roman numeral. And they're given a Roman numeral to represent the order in which they connect to the brainstem from superior to inferior. Meaning the most superior cranial nerve to plug into the central nervous system is the olfactory. In fact, it's so superior, it runs straight from your nose, like up under your frontal lobes. It doesn't even have to plug into the brainstem. But then we get down to the brainstem, and you can see that you have the optic nerve, and then coming a little bit more inferiorly, oculomotor, trochlear, trigeminal, and then the rest of them come in below. So the cranial nerves are numbered in the order at which they connect to the nervous system from superior to inferior. So looking at this list here, I know that the olfactory is the superior most cranial nerve in the body, and I also know that the hypoglossal is the inferior most. Your cranial nerves are paired nerves, meaning you have a right and a left. There are a lot of mnemonics that are far more memorable, and you can find these on the internet. But for the sake of not saying anything inappropriate, and also for the sake of tradition, here are the two classic traditional bookish mnemonics for the cranial nerves. First one is the mnemonic that helps you remember the order of the cranial nerves. And this is: on old Olympus's towering tops, a Finn and German vied at hops. So O for olfactory, O for optic, O for oculomotor, T for trochlear, T for trigeminal, A for abducens. You get the picture. Vied at hops, meaning that they're having a drinking contest. So some of the cranial nerves are motor in nature, meaning efferent only. Some of the cranial nerves are sensory in nature, meaning afferent only. And some have both an efferent and an afferent function. The mnemonic that allows you to remember which is which, this is the most traditional one. Some say Marilyn Monroe, but my brother says Bridget Bardot. All right. S meaning sensory, M motor, and B referring to both sensory and motor. And that way, that allows you to remember which ones are only sensory, which ones are only motor, and which ones have a dual function. We're going to spend a lot of time in future classes going through the cranial nerves. But I'm going to go through them here as I want you to know them in this class, and this is a pretty solid starting point for understanding the cranial nerves as a whole. The first cranial nerve, the olfactory, you don't have any muscles that you move your nose with. There's no motor signal being sent to your nose, right? Your nose is only a smelling device. It's not a moving device. So the olfactory nerve is only sensory. It is for smell. The optic nerve is the wire that runs from the back of your eye, the retina, to your thalamus, and then to your occipital lobe to deliver visual sensation to your brain. So optic nerve, vision from the eyes. The optic nerve is only sensory. But the oculomotor, the trochlear, and skipping the trigeminal for now, and looping in the abducens, these three are responsible for motor movement of the eyes. That's all I want you to know for these three. Oculomotor, trochlear, and abducens. Think motor to the eyes. Now let's back up. The trigeminal. This is a very speechy cranial nerve. The trigeminal is responsible for transmitting sensory information from the face to the brain, and it's responsible for transmitting motor information, efferent information to the mandible, the muscles of the mandible, the temporalis, the masseter, the pterygoids. So motor movement of the mandible, that is a function of the trigeminal nerve. So now we've already made it to the seventh cranial nerve, the facial nerve. The facial nerve does motor to the face and sensation from the anterior 2/3 of the tongue. Don't confuse the trigeminal, which does sensory from the face, and the facial that does motor to the muscles of the face. Don't confuse those. Trigeminal does sensory from the face, motor to the mandible. Facial does motor to the face, sensation from the anterior 2/3 of the tongue. Cranial nerve 8, the vestibular, or I usually call it the acoustic nerve. This is the nerve that is responsible for transmitting that signal of hearing from your cochlea up to your primary auditory cortices in your temporal lobes. It also does the acoustic reflex, which is a tiny little motor reflex to restrain the ossicular chain, but it's fine to think of the acoustic nerve as sensory. Olfactory smell, optic vision. So olfactory smell, optic vision. Oculomotor and trochlear, motor to the eye. Trigeminal, sensation from the face, motor to the mandible. Abducens, motor to the eye. Facial, motor to the face, sensation from the anterior 2/3 of the tongue. Acoustic, sensation from the ears, so hearing. Now we've made it to cranial nerve 9, glossopharyngeal. The glossopharyngeal does taste sensation from the posterior 1/3 of the tongue, and it also does motor to the pharynx. So motor to the pharynx, pharyngeal constriction, that's for swallowing mostly. And 10 vagus is a large nerve with many parts. It is often referred to as slang for the vagus is the wanderer because it goes throughout the body. The vagus innervates the velum. The vagus innervates the inferior pharynx, motor, so motor to the velum, motor to the pharynx. The vagus innervates the cricothyroid muscle, which is responsible for tensing the vocal folds. The vagus innervates all the muscles also of add and abduction, so all the intrinsic muscles of the larynx. And the vagus is also responsible for transmitting sensation from the larynx. So the vagus is a cranial nerve that, as speech therapists, we worry about a lot and we think about a lot. 11 accessory, think of this as being secondary to the vagus. This is the accessory to the vagus. So think of the accessory as helping the vagus accomplish the things that the vagus does, but it also helps innervate some of the muscles of the neck and shoulders. And hypoglossal 12, motor to the tongue. The trigeminal is a large cranial nerve with 3 parts. One up here, which is your ophthalmic branch. One down here, which is your maxillary branch. And then another one at this angle, which is your mandibular branch. So you can see it illustrated here. That is a big nerve that covers most of your face. The facial nerve, motor to the face. So all those facial muscles that you learned, zygomatic minor, zygomatic major, orbicularis oris, risorius, all those are innervated by the facial nerve. All those muscles get their efferent signals from the facial nerve. And then facial nerve also transmits sensory information from the anterior 2/3 of the tongue. And just so you know, at the base of your spinal cord, the spinal cord turns into all these peripheral nerves that looks like a horse's tail. And so it's the Latin for that is cauda equina. So this is what happens at the sacrum. That's what your spinal cord turns into.